And what would we say for that?
Equal.
Equal, because the 1 and 2, 1 and 3 is open. It's just a series circuit with the 2 bulbs in the same loop, so you have the same current through them. And then that was worth 1 point, and we said bulb 3 was going to do what? And when the switch is open?
Off.
It's going to be off because there's no path for the current to flow. There'll still be a potential difference across it, but there's not a complete path for the charges to flow. That's worth half a point.
Oh, okay.
Yeah.
How much is, yeah.
Continue.
Half a point.
I missed it.
Don't be mean.
I'm paying something.
I'm trying not to. I'm trying to be less mean these days. A and B, questions? Okay, let's jump down to C, D, E. When I close the switch, what happens to bulb 3? It should turn on. Now we're completing the circuit. And how will the brightness at the end be between the 3 bulbs, do we think?
Dimmer.
So at the end, we know that 1 is going to be the brightest, and that 2 and 3 have to be the same. Those 4 parts, why? Because they're going to have the same voltage change across them because they're in parallel, and they have the same resistance.
In the same series as one.
Once the switch is closed now, so good question. Now I've closed the switch. How many loops are there at this point? 2 loops. 1 loop here and 1 loop there. So both of those loops have to use up the same number of volts. Let's say this is a 9-volt battery, and this one used up 6 of those volts. These have to both use up 3. So once you close that switch, that series circuit is gone now.
Okay. Yeah, but it won't ever go through both of them. 2 and 3.
Right, but an equal number of electrons will choose this path as will choose that path. Okay, now the tricky question. 2 in the middle.
How much was E?
Wait, which one?
Which ones are not 0.5?
A was worth 1, B was 0.5. I think the bottom 2 are both worth 0.5.
What about D and C?
C was worth 1.5 and D was worth 1.
Wait, did you C was worth 1.5?
That's how important it is.
Wait, did we say okay? Well, C, I got 0 total.
We haven't done C and D yet.
Okay, that needs to be explained.
That's the hard ones.
Okay.
Okay, I'm going to erase my lines here. Here's the short answer for C and D. 1 will get brighter and 2 will get dimmer and be the same as 3. A lot of you wrote down some of those things, but your reasons were either guesses or they weren't necessarily 100% correct. A lot of people gave points for D on but not for C because you were kind of right but not all the way. So let's draw that again. I can erase the whole thing.
So explain a good answer for C.
Really
I'd love to.
Okay. Well, because I got 0.
Most people did.
But I feel like my answer is
Okay.
sufficient.
So let's pretend a couple things. Let's pretend that this is a 9-volt battery.
Same brightness. He says it's brighter.
Hi.
L1 gets brighter. Excuse me.
Let's pretend this is a 9-volt battery. So when the switch is open, I have how many loops? 1 loop. Just these 2 bulbs over here. So they would each take up 4.5 volts, so to say. And that's where you can have defined that, and we'll say they each have a resistance of 1 ohm, so they each have a current of 4.5 amperes initially. Is that okay? So that's going to be kind of our baseline comparison. And now what we're asking here really is what happens to bulb 1 and 2 once that switch is closed. We know bulb 3 will turn on, and it should match up with bulb 2 just because of what we've already said. But we want to figure out what's happening to bulb 1 and bulb 2. And really, the key bulb here is bulb number 2. We know bulb 1's brightness is going to be the sum of those 2 currents. So we got to figure out what bulb 2 is going to do. And it's really the crux of the whole question. So when I close that switch, how many options do I have for what bulb 2 could possibly do? The 3 options, right? Bulb 2 could get brighter, could stay the same, or it could get dimmer. Agreed? Could turn on. That is the same as dimmer. I'll classify that as the same as dimmer. I'm going to just maybe pull my teacher card, or maybe, I think most of you do this thing too. I'm going to say bulb 2 is probably not going to get brighter. I don't really have any reasonable reason to think this bulb is going to get brighter from closing this switch. And we did that thing up here earlier in the year where we screwed the bulbs together, and the bulbs never got brighter. They all stayed the same. Now, this bulb does end up getting dimmer, so that's the best example, but I know it's not going to get brighter. I'm going to take that one off the table. So now bulb 2, this is bulb 2 still, is either going to get the same or it's going to get dimmer. So I'm going to make a hypothesis here. This is exciting. Hypothesis is that bulb 2 will not change currents. Okay? What people in stats might call a null hypothesis, right?
Wait, you really don't have a reason why?
Well, the reason why it doesn't matter right now. Listen, my hypothesis is that, well, sure, my reason why is that the current's just going to split. There you go. I'm going to prove why. It's my guess. So, I'm going to attempt to prove my guess, and then we'll know what the answer is. Are you ready? So, if bulb 2 does not change currents, what is the current through bulb 3? We're going to close the switch now. If this current doesn't change, what's bulb 3's current? So we said it's going to be the same. It's going to be 4.5. I close the switch.
Okay.
That's right. It's the same potential, same resistance, so same current. Agreed? So if bulb 2 doesn't change, bulb 3 also has to be 4.5 amps. Roger? Roger. What is, so now these are no longer going to be true. So now if those two things are true, what's the current through bulb 1? 9 amps. And so what's the voltage drop across bulb 1? If it's 1 ohm resistance? 9 volts. Is that possible? Is that V equals I times R?
Oh, yeah.
What gets split? Why? Is this now a legal circuit?
No.
Why not?
It's illegal.
Why is it illegal?
Yeah.
Or the sum of these is more than 9 now, right?
Yeah.
It's going to be, no matter what loop I take, it's going to be a sum of voltages of 13.5. Well, I only started with 13.5. We don't go through both of those. We'll go one or the other. 13.5, we only have 9 to start with. So this means this theory must be wrong. So what must happen is that this brightness goes up bigger than 4.5 amps, and this one has to go lower than 4.5 amps. Why does that have to get brighter? Because now it's going to have, before it was just 4.5 amps, now it's going to have two numbers that are both lower than 4.5 amps. I suppose they could drop down to like 2 each, but that's not going to happen. So like, these are both going to be like 3 now. Because then you wouldn't be using up enough of the voltage, right? Because if these are both 2, that means this is only using up 2 volts. And that means this would only use up 4 volts. That's not 9. So really, it'll probably end up being like 6 and 3 for the voltage on both of those bulbs. Or just still count up back up to 9. Yes, I'll lay down.
How come it's not like the first bulb isn't the same as the other circuit, and then the other two are just split up the remainder? Yeah. Because that's what I would think. Yeah.
Because then, so you want this to stay at 4.5 amps, and these to be 2.25 each.
Yeah.
So now this is still going to have 4.5 volts to it, right? So this is only going to be 2.25 volts. That plus that doesn't equal 9.
Why can't they all be?
They can't all be 4.5, then this one it has to be 9.
Isn't it the 2 plus because they meet at the junction?
Say it again?
Isn't it the sum of all 3 of them?
No, but any individual charge will only go like that or like that. It won't zigzag back through that third bolt. So one loop has to add up to 9.
That makes sense.
Wait,
Voltage
I forget why.
Voltage, yes. Voltage. Some of the voltages.
Is equal to 0.
Why can't L1 and L2 be the same?
Only if you get it.
No. I thought it was
Is it up to 9?
So that means they're both 4.5.
Yeah, why can't they both be? That's what I was
That means this one also has to be 4.5.
Yeah.
But then, if these are both 4.5 amps, the junction rule says this one actually has to be 9 amps.
That's what I said.
Don't they meet up at the junction?
Yeah.
Okay,